All right, so we covered the first three topics: correlation, assumptions, and confidence intervals prediction plots, or intervals rather, sorry. So for this one, we still need to go over an example where we discuss the interaction term. Okay, so I sent you this code. Okay, so basically I want to use these examples just to really kind of look at the interaction term. Okay, technically what these data sets are using are, there's a couple binary variables, um, which really they're basically nothing different than what we've seen before. It's just the interpretations, okay? But I'm not so worried about that. Um, so I don't want to worry about the values that the x's are taking so much. I just want to look at this. Okay, so what do we have? Um, we've got yield. Okay, so in this example, the variables that we have are crop yield, the nitrogen level in the soil, the phosphorus level in the soil. Okay, so those are our three variables, and here you can see where we are fitting an interaction term for nitrogen and phosphorus. Okay, um, summary reg.model, but let's just look here. Okay, it looks like, let's go ahead and just use our generic 0.05. Right, these two are less than 0.05, indicating that it looks like nitrogen and phosphorus are needed in the model. But the p-value for nitrogen and phosphorus is higher, right? It's higher than 0.05, indicating that this interaction does not appear to be needed in the model. Okay? So that's really, if you are trying to see whether the interaction is needed or not, one thing you can immediately kind of see is if you see a high p-value, you basically have evidence that the interaction is not needed. Again, what the interaction means is, of course, this says yes, nitrogen is related to yield. This variable says phosphorus is related to yield, but an interaction between nitrogen and phosphorus means that together their unique values determine and influence crop yield. Okay, meaning that, for example, maybe when nitrogen is lower, that impacts how much of an effect the phosphorus level has, right? So maybe when nitrogen is low, then the effect that phosphorus has isn't as much, but maybe there's some chemical reaction between nitrogen and phosphorus such that when we have high nitrogen, now whether we have low or high phosphorus matters a lot, because when we have phosphorus and nitrogen together, they interact in some way to affect crop yield, right? So that's basically understanding the interaction. Okay, so basically the same three variables, but I'm going to look at a different, I'm going to modify the data, okay? So we still have our three variables, nitrogen, phosphorus as our predictor variables, and corn yield or crop yield as our variable of interest. Okay. Well, here's something interesting. It looks like neither nitrogen nor phosphorus is useful in predicting crop yield, and it looks like together nitrogen and phosphorus account for 6% of the variability in crop yield. Okay, so based on these numbers, it looks like nitrogen and phosphorus are not helpful in predicting crop yield. Okay, but we can't, even with a model like this, where it's like, okay, this model's completely useless because it appears to basically be completely useless. Nitrogen isn't important, phosphorus isn't important, right? These are above 0.5 and actually far above it. And we account for almost none of the variability in crop yield. But we would still need to look at our assumption model, okay? And we see a clear pattern, right? And what this is indicating to us is that there is something wrong with the model, okay? It is indicating to us that maybe some sort of a squared or interaction term might be needed. There's something needed in the model, okay? So maybe it is in fact possible to relate nitrogen and phosphorus to yield, right, in a useful way, because right now it's basically not even useful. But this is telling us that something's wrong. We're not modeling it properly, okay? And of course, looking at the normality plot, well, the normality plot looks fairly good. Okay. One thing that I can do is, what's my data set called? Or it's not even called anything. Plot yield versus nitrogen. Oops. Nitrogen is X, yield is Y. Okay, this is why I said the X values. You're not going to get much from these. Okay, I'm not going to give you variables like this because technically for nitrogen, all I have is basically a 0 or 1 for low nitrogen versus high nitrogen. Okay, it's really not all that tricky to work with. It's just technically that is the chapter, the next chapter, which we didn't get to. Okay, so anyway, basically what you could do, the reason you could try all of it, but the reason why you might look for an interaction term as opposed to a squared term is basically you could look at a plot, scatter plot of nitrogen versus yield, and kind of clearly see that there's not some squared pattern. And you could do the same for phosphorus versus yield and kind of clearly see that there's not a squared pattern. And those would be indicating to you that it doesn't maybe look like a squared component is needed, so we might want to try an interaction term. Okay, because we still clearly in that interaction plot had some curvature, which indicates usually a squared term or interaction term. Okay, and so if the scatter plots between nitrogen and yield and phosphorus versus yield don't look like there's some nice evident squared pattern, then that is kind of further evidence that we might want to look for a squared term. So now I'm going to fit the model. I'll call it reg.model2, but now I'm going to put the interaction term. Okay, so just recalling what we got when we just fit no interaction term, basically useless, accounted for none of the variability almost. Okay, so now let's see what happens for our model when we include an interaction term. Now, I don't know that you could get much of a better indication that there's an interaction term. Notice now we're getting lower p-values, right? Just looking at the interaction term p-value, it's actually high, it's very significant, right? It's less than 0.05. Okay, technically phosphorus is still above the 0.5, but now nitrogen is still far below 0.05. So notice how adding the interaction actually changed these quite a bit, right? These say, okay, these are useless. These say, right, these are useful or maybe, right, slightly outside the bounds of useful, okay? However, if you recall what I've said before, the interaction term between nitrogen and phosphorus is useful, right? P-value less than 0.5. So we're saying that beta 3, right, beta 1, beta 2, beta 3 is not equal to 0, so this is useful. And so because phosphorus is useful in this interaction term, even though maybe we could, based on this p-value, kick phosphorus out, because it's useful in this higher order term, like an interaction term or a squared term, we don't kick out the lower order term. So everything should actually be kept in this model. Okay, this of course says it should be kept, this says it should be kept, and this slightly above our 0.5, but because phosphorus is in this interaction term, we don't want to remove the single phosphorus term from the model. Okay, and now also look, our model, right, we're still only using nitrogen and phosphorus variables, but we now include the interaction term. Now we account for over 50% of the variability, whereas the first model accounted for 6%. Okay? So what this is saying is that phosphorus and nitrogen are interacting in a huge way to impact crop yield, right? There is some chemical reaction between nitrogen and phosphorus, okay, such that nitrogen alone doesn't really do anything to affect crop yield. Phosphorus alone doesn't do anything to affect crop yield, right? Basically like this. But together, right, they interact with one another in a special way to affect crop yield, okay? And so they are actually very useful. And so if you just were to fit this and not say, look at the assumptions to, right, because you might not even think, why would I want to check the assumptions of a useless model, right? This model appears to be useless. Why would I check the assumptions, right? Well, this is one of the reasons, is because that you can discover that maybe these are actually useful, but you just haven't put the right kind of function of them, right? You might need a squared term or an interaction term, something like that. And in this case, we can see this interaction term is highly significant, and these two together are actually very useful in predicting crop yield. Okay, so we still want to check the assumptions of this model. As we saw in our last example, um, when I added the squared component, it looked like the squared component was needed, and I was actually expecting that to kind of fix everything, but actually more work was needed. It still didn't completely fix it. So what we don't want to see, right, is that squared, right, that quadratic. What we want to see is a nice straight red line. And right, there's a little bit of wiggle, right, but it's pretty darn straight. Okay, that looks much better than it did before. Okay, but again, we can't stop at just looking at a straight red line. We do need to make sure that the other assumptions are satisfied. So now we're kind of looking at the spread, and now I want to say the only reason that there are only, say, 3 lines, that's not a bad thing. It's just because of the x values only taking 2 values. So in general, we would just look at the scattering across the y-axis. Okay, so again, the fact that they're kind of in 3 lines isn't the issue. What you want to look at is the spread on the y-axis. So looking at the spread on the y-axis, it's fairly similar here and here, and maybe it goes down a little bit here. Okay, but it doesn't, even if you try to look at like a reverse megaphone shape, I'm not sure that we quite have that really. It could just be, right, there's not very many data points here. So it doesn't look like there's a terrible amount. Maybe you could consider a slight amount of non-constant error variance, right, because the spread here is roughly similar to the spread here, but the spread here is not as much, right? We would want these to be wider for the spread to be the same. So you might mention that there does appear to be some slight amount of non-constant error variance, but I would say that alone would not cause me to not use this model. Okay, now if it was a huge amount, like if all 4 of these points were like right here, and then these points were a little closer, and then these points were really wide, that would probably cause me to say, okay, we need to use another technique to try to fix this. Okay, but of course there also doesn't appear to be some correlation or anything else going on really here. Okay, looking at the normality again looks very good. Okay, so overall this model appears to be the assumptions again, mentioning possible slight amount of non-constant error variance. But besides that, everything appears to be good on this model, and I would be happy going forward using this model. Okay. Another thing about the interaction term, okay, we determined this, right, why we need it, right? This is saying that it's needed, and we also discovered when we tried to fit the model without it that there were problems, okay? And so that they were almost entirely fixed when we added this interaction term. Now, one thing that it does do, okay, for the model like this where we just have nitrogen and phosphorus, right, we have nice interpretations. Whenever we increase nitrogen by 1, we increase crop yield by 1.6, holding phosphorus constant. Remember, you have to add that little line when we have multiple variables. And for phosphorus, whenever we increase phosphorus by 1, we decrease crop yield by 2, holding nitrogen now constant, right? But besides saying holding the other variable constant, these have nice interpretations. With the interaction term, that goes out the window, okay? Because now when we increase nitrogen, it matters whether the level of phosphorus, okay? And so basically now nothing is interpretable. However, this model is useless, right? This model is useless. This model is appears to be quite useful, right? Okay, so we do unfortunately lose the interpretations, but sometimes you have to sacrifice interpretability for a slightly more complicated, right? It's not terribly complicated, it just includes an interaction, but sadly that does still kill the interpretation of these coefficients that we had before, right? Again, this is beta naught hat, beta 1 hat, beta 2 hat, beta 3 hat. Okay, those really maybe beta naught hat might still be interpretable for when these are 0, but beta 1 and beta 2 lose their nice interpretations that they had before. Okay, and beta 3 not interpretable either. Let's see. I think for these prediction and confidence intervals, you can do it on a model like this, but I think for these, I'll probably just save that for the simple linear regression when you only have one x, right? So you just have to put one x here. So I wouldn't worry about that in the multiple linear regression case like this, right? When we have multiple x variables. And so that should be basically it. Okay. So again, if you do have any questions, feel free to email me. Right? The sooner you do it, the better. Right? If you wait until Wednesday night or Thursday morning, I probably won't get to it. Okay. Study hard and good luck on the final.